Hey everybody, Mac here, and we are talking about multiplying rational expressions, which basically means we are going to be multiplying fractions, everybody's favorite. Okay, now this is version B, meaning that there is a version A, and there's also a video of me doing this on a whiteboard to help explain it to you. Now, you have to do version A because I did these all kind of sequentially where they get harder each time. So for you to really do version B, you should have seen version A, and you can just go down to maxtutorials.com, and I have them all there under my section on rational expressions, okay? Well, let's go ahead and get started. I'm going to zoom up on this. What I explained in version A and on the board is that you can't just start doing this. Oh, x, and there's an x squared, and there's a 3, and there's a 9, and let's cancel things out. You can't do that. You're only allowed to do that when you're multiplying. And right here, this x is not being multiplied by anybody. It's being added. Same thing with this x squared. That x squared is being subtracted by something, so it's not a factor. It's only a factor if it's multiplying. So these x2s, think about it like this. Those plus and minus signs are like glue that holds them together. And while those pluses or minuses are there, and while anything, a number or a letter is attached to a plus or minus, they're stuck. You can't cancel them out. But what I can, hopefully you start to recognize these, and we've been doing enough of them. You see that as a difference of two squares, and that's going to be x plus 3, x minus 3. And you see this one as an x plus 1 and an x minus 1. Now, that is a factor. The entire parenthesis is a factor. That entire parenthesis is a factor. That entire parenthesis is a factor. That entire parenthesis is a factor because the parentheses are being multiplied by each other. Heck, even this x plus 1 is a factor, and even that x minus 3 is a factor. Not the x, that's not a factor. The 3 is not a factor, but the entire x plus 3 is a factor, just like the x plus 1. So now I actually have 6 factors here. Now, if an entire factor is the same, you are allowed to cancel out. So this x plus 1 down here can cancel out with that x plus 1 up there. This x plus 3 here can cancel with that x plus 3, but it has to be the entire thing. And what's left over? X minus 3 over x minus 1. Now, can I cancel out the x's? No, because they're attached to those minus signs, so they're not factors, so you can't do it. Okay, let's keep doing them until we start to feel comfortable with that idea. X plus 4, x minus 4. You always have to factor first to do these problems. Okay, boom. Now, those are done. I just restated them. Now I see I have an x plus 5, and I have these x minus 4s. And my answer is going to be x plus 4 over x minus 5. And that's my final answer. I cannot cancel out the x's, okay, because they're not being times by anything. Number 3, difference of squares. X plus 6, x minus 6. X plus 2, x minus 2, okay? X plus 2, x plus 2, x plus 6, x plus 6. What's left over after I cancel everybody out? X minus 6 over x minus 2. Can I reduce the 6 and the 2? No, because they're attached to minus signs. Okay, and once we do that, we can't cancel them. Okay, how about this one? That's going to be difference of squares, x plus 7, x minus 7, and this is going to be an x plus 3 and an x minus 3. Okay, x plus 3, x plus 3. And what's left over? An x plus 7 over an x minus 3. Okay, that's supposed to be a 7. There you go. Okay, next one. Still the same thing. They're just giving us difference of two squares. They're really trying to hammer us home right now on this one concept, which is fine. We can use the practice, but hopefully after doing a few of these, you're starting to feel comfortable. So when you see these on the test, you know what to do. Okay, remember, you can always cancel out an entire set of parentheses. But you can't do a portion. Those are connected to pluses and minuses, so I can't reduce those x's and the 8s and the 4s. Okay, boom. X plus 10, x minus 10, boom. X plus 5, and an x minus 5. Okay, x plus 5, x plus 5, x minus 10, x minus 10. What's left over? X plus 10 over an x minus 5. Boom. Okay, number 7. Now, remember, you got to factor this however you can. This one, you always start with the what's the same. And I can always pull out, I'm looking here, I can pull out a 3 and I can pull out an x. What's left over? X minus 4. How about this one? X plus 4, x minus 4. All right, guys, let's go at it. I see an x plus 4 here and an x plus 4 here. I see an x minus 4 on top. I see an x minus 4 on bottom. All that's left over is my 3x and my 6, but look at this. 3 goes in there once, 3 goes in there twice. My answer is x over 2. These are going to be kind of fun after a while. You get these really nasty numbers, and then all of a sudden you find out it's just something simple like that. Okay, how about this? Okay, I can see that I can pull something out that's the same. I can pull out a 5x, and I'm going to be left with an x minus 4. Interesting, okay? This one's going to be an x plus 5, and this one's going to be an x plus 5 and an x minus 5. All right, well, let's go to town. X plus 5, x plus 5. I can't do the parentheses, they stay. I have a 5 and a 10 that can reduce to a 1 and a 2. So my answer, and you write it like this. On top, it's just going to be x parenthesis x minus 4. And on bottom, you're going to put the 2 in front of the parenthesis, x minus 5. There's nothing else I can factor. I can't do the x's. Okay, that's it. Boom. Okay? Here we go. Let's go on to, wow, number 9. I got a lot on here. I can pull out a 2x, and I'm left with an x minus 9. Down here, I'm going to get an x plus 9 and an x minus 9. Okay, because I'm a pro at my difference of 2 squares now, because we've been doing a lot of them. Boom, boom, and then watch this. 2 goes in here once, 2 goes in there twice. My answer is x over 2. That's a weird looking 2. There you go. Okay, cool. That's it. We're going to go on to the next one. All right, is there something the same I can pull out of here? There is. I can pull out a 4x, which is going to leave me with an x minus 9. This is going to leave me an x plus 3 and an x minus 3, and that's fully factored. So here we go. X minus 3, x minus 3. The 8 and the 4, I can go 4 goes in there once, 4 goes in there twice. What's left over? X minus 9 over 2, x plus 3. I can't cancel out any of the x's. I can't cancel out the 9 and 3. They're all attached to pluses and minuses. Now, if that said 2x, because that x would be multiplying, I could cancel with the x above. But the only x I have down there is being added, so he's attached. I can't move him. Let's go on to number 11. Okay, here I can pull out an x, and I'm left with an x minus 5. And down here, I've got an x plus 5 and an x minus 5, difference of 2 squares. Now, x plus 5, x plus 5, x minus 5, x minus 5. What's left over? There's only an x on top, and there's only a 2 on bottom. How about number 12? What's the same on top? I can pull out an x. I'm left with an x minus 8. Down here, I'm left with an x plus 4, x minus 4. Now, that x plus 4, boy, that's it, isn't it? I'm done with an x minus 8 over 4, x minus 4. Now, sometimes because it gets really busy, you don't see everything, you cancel out. So once you multiply across, always look at that and check, hey, did I miss something? Now, we didn't. That's fine. But always take a look to see if you may have missed something. All right, 13. This is different. On this one, I see third term positive. So we're going to factor like this. Remember this? Third term positive, signs are the same. Take the sign of the middle number. What multiplies to 9 and adds to 6? 3 and 3. We did all this in the factoring section. And this is going to be an x plus 3, x minus 3. All right, let's go to town, guys. X plus 3, x plus 3, x minus 3, x minus 3, x minus 3, x minus 3. What happens when everything cancels out? It's a 1. Remember, if you have the same thing on top as the same thing on bottom, it's a 1. Don't write a 0. Okay? That was fun. Let's do this one. Boom, boom, boom. This is actually the difference of two squares. We were doing this and completing the square, so hopefully you recognize it. But it is nice to write them twice because you know you're going to be canceling. So we're just going to do the x, third term positive, signs are the same. Take the sign of the middle, what multiplies to the third and adds to the second. And this is difference of two squares. We're going to have an x plus 5, x minus 5. And now we're just going to go to town. X plus 5, boom, boom. X minus 5, boom, boom. X minus 5, boom, boom. This is also a 1. Okay, let's go on to number 15. This one is going to be an x minus 2, and an x minus 2, and an x plus 2, and an x minus 2. And I see a pattern here. Boom, 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 boom. This is also going to be a 1. Okay, is the other one? Yeah, I think the next one's going to be, my gosh, are they all? Maybe, maybe not. I got to work it out. Okay, it's going to be a little bit different. Wow, we really got excited with that 1 for an answer, didn't we? Okay, here we go. So 2 parentheses, and I see this as x and x. Third term is positive, signs are the same. Take the sign of the middle, what multiplies to 49 and adds to 7. 14 is 7 and 7. This is a difference of two squares, so we're going to get x plus 7, x minus 7. And now we're just going to cancel away. X plus 7, x plus 7, x minus 7, x minus 7, x minus 7, x minus 7, 1. Okay, and it looks like that's probably going to happen here too. But now the difference of two squares is on top. Oh, why do I write a 4 there? Sure, 6. And then x minus 6. Boom. This is going to be an x minus 6 and an x minus 6. Now let's cancel away. There's an x minus 6. 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 There's an x plus 6. There's an x plus 6. It's a 1. All right, and 18. Okay, well, this one's different. I got to just pull out a 2, and I'm going to get left an x squared minus 25. Okay, now, the next step would be for me to factor the x squared minus 25, but look on bottom. I have an x squared minus 25. If the entire thing is the same as the entire thing, you are allowed to do that. Okay, remember, it's the entire parenthesis and the entire denominator. If it's the portion of that, you can't. Okay, so 2x plus 5 over 4 is not my answer because I got to do my 2 and my 4. I should have looked at that, but I didn't. That's going to be x plus 5 over, that's a 1, that's a 2. 2. Bingo. Okay, and that's my final answer. So just to hit that point home, if I have this, x squared plus 3x plus 8, I don't know, I'm just making up numbers, over x squared plus 3x plus 7, am I allowed to cancel out that x squared plus 3x? The answer is no, I'm not allowed to do that. Okay, but let's pull this part out. The entire thing over the entire thing, am I allowed to now cancel that? The answer is yes, I can. Okay, as long as it's the entire thing. All right, guys, there's B. C's going to get a little bit tougher, but it's going to be the very similar process. Do C, and you guys are in really good shape.